Good morning, everybody. Welcome to Important Morning of Chem 1105 with your host, me, Dr. White. And good morning to you, Ruben, and everybody else. All right, couple important things. Remember, Friday, I will be giving test number one online. We will not have a Zoom lecture on Friday. At a little before 10 o'clock, I will send each of you an individual email with the password for which version. There are two versions, cleverly named version A, and to fool you, version C. And half of you will get one version, the other half the other. They're almost identical, but there's enough difference that I can tell if anybody's cheating. Please don't. I don't know if I mentioned it. There are two things in life that get me real mad, and you don't want me ever real mad. Guess what? I don't want me ever real mad. It's scary. But anyways, uh, one is people who lie to me, and two, students who cheat. I will do what is in my syllabus. And since I've been teaching online for a while now, I've come up with some very clever ways to find out if anybody is A, going on the internet, B, getting help from anybody else. So don't, please. And on Friday, once you get your password, sometime later today, normally it's the day before, but tomorrow is Yom Kippur, the high holiday, Jewish high holiday, which I'll mention something about that in a second. But later today, I'll post in the assignment area, test number one. I'll have the two PDF files. You can download both and use the one you get the password for. And also, I'll have a periodic table and the files you've seen how to scan and upload a test or a lab like you've been doing. You'll have until 11:30 to take the test and upload your answers as a single PDF file. I give the extra time. So if you have any problem with your scanner or doing it, it takes extra time. Most students tell me they can do it in about 5 to 10 minutes, usually about 5-6 minutes. Most of my tests, even though if we were face to face, I give you 50-55 minutes, most students on test one are done in about 40 minutes or less. Don't forget, the last page of test one will have important information, and also use the green periodic table that will be in the assignment area. All right, that's one thing. Another thing, I apologize, but I didn't have time to upload, maybe this afternoon, for sure by Saturday morning. Any of you who handed in labs late, I worked on catching up yesterday. I just didn't have time yesterday to upload the lab scores from late labs. Also later today, if I have time, I'll do the lab you handed in, hopefully yesterday, and I'll do that. Finally, this is important. Tomorrow is Yom Kippur, a high holiday of the Jewish calendar. And because of that, from sundown tonight till sundown tomorrow night, Thursday night, I will not be looking at my email, period. I won't even turn on my computer. It's a high holiday. And so I just wanted you to know that, because usually I check my email twice, usually more each 24-hour period. This is one of those rare exceptions. All right, what I'd like to do now is my review for test number one. There's one caveat I should mention. On my test, every question, I'll cover the concept at least twice in lecture. Once in a very rare time, I'll forget to talk about a concept in my review. If I've covered in class, lecture at least twice, or the pre-lab where we go over problem sets, it's fair game on a test, even if I forget to talk about it in the review. I don't think I did forget anything, but that's an important caveat. All right, let's get to work. All right, first of all, If you look in the lecture section of Blackboard near the bottom, you'll see secretly labeled Chem 1105 test number 1 review. Everything you're seeing right now is available for you to download. All right. First of all, you should know at least one of the 4 branches of chemistry. The best is organic, but I'm biased. I'm an organic chemist. Then there's physical, analytical, and inorganic. Now, what is matter? And you should know matter is anything that has mass and occupies space. You should also know the chemical symbols for the 37 elements that I gave you, asked you to learn. You don't have to learn the whole periodic table like some instructors, just the 37. An example, let's go to periodic table. And one thing I should mention, if you open your periodic table, the one I send you in on your computer from Blackboard, and it's oriented wrong, Control-Shift+ rotates it 90 degrees clockwise, Control-Shift- rotates it 90 degrees counterclockwise, which every time I open it up, I have to rotate this 90 degrees clockwise so you see it like it is. This is the periodic table you should use. And you should know H is hydrogen, C is carbon, N is nitrogen, Br bromine, and so on for the 37. Oh, let's do a high rent district one. Au gold, Ag silver. And you should know that. Next, we went over, oops, let me move this out of the way. Next, we went over the 3 states of matter. Remember, I had you do, if we were in class right now, we'd do a class participation. I'd say, class, everybody with me. The first one is solid, second one is liquid, and the third one is gas. And you should know solid has definite shape, definite volume. Liquid has indefinite shape, indefinite volume, and gas has indefinite shape, indefinite volume. And again, the 3 states of matter, you should know solid, liquid, gas, and their definitions. Again, this file I'm reading off of is available in the lecture section of Blackboard. Next, matter. There are 2 types, pure substances and mixtures. Looks like I spelled, gotta look at the M and the I for a second. I thought, oh, I just forgot. A lot of you can't read cursive. Uh-oh. Well, future ones, I'll have to rewrite this. I apologize. If you have trouble with this in cursive, email me. And if enough people email me, I'll rewrite this, print it out or type it out. All right, you should know a pure substance is either an element or compound. Example, gold is a pure substance, and water, when it's not polluted, is a pure substance. Oxygen gas is a pure substance. Now, next we have mixtures. And mixtures are when you combine 2 different compounds or an element and compound, and there's no chemical reaction. Each one retains its own chemical identity. I'll never ask you that. But when we talk about mixtures, there's 2 types you should know: homogeneous, heterogeneous. Homogeneous, it's the same throughout. Homogeneous, the same throughout. Heterogeneous, it's not the same throughout. An example, homogeneous, would be if I took some salt, put it in water, stirred it real good, guess what? It would look the same throughout. But if I take that same water and put in some sand and stir it real hard, the sand goes to the bottom. It's higher density, and you learned about that. And the water mainly is on top. And that's because it's not the same throughout. Next, I talked about properties of matter. and there's physical properties and chemical properties. Physical properties tell you about how something looks or appears, and chemical property is how it will react or change. Example you should know of a physical property is my shirt or t-shirt is black. The color is a physical property. Now, chemical property would be gasoline is flammable. It burns. Water is not flammable, non-flammable. It's used to put out fires. Now, when we talk about matter, there are properties and then there are changes in matter. One is a physical change. And a physical change in matter is when it changes its state. Water boiling, going from a liquid to a gas, would be a physical change. Another one would be if you had an ice cube and it melted, it's going from a solid to liquid. Or if it's wintertime and you put a bottle of water outside, forget about it. Next morning you come and see it's solid. It's gone from liquid water to ice, solid water. That's a physical change. A chemical change would be example when, oh, did I tell you most organic chemists when they were young were pyromaniacs? We love to burn things, myself included. Luckily, I never burned down my parents' house. I came close once, but not by choice, by accident, but I try and forget that. If you light a candle, the wax is burning, and that's a chemical change. Not to scare you, but I will. If you chew some food and swallow it, when it goes in your stomach, it's undergoing a chemical change and the food is converted into other molecules. In other words, you eat protein that's broken down to amino acids. Now, I talked about the temperature scales, Fahrenheit, degrees Celsius, and Kelvin, degrees F, degrees C, and the K, Kelvin. And I showed you conversion formulas. To go from degrees C to Fahrenheit, degrees F, use the first one. Remember, 1.8 and 32 are exact numbers. On test number 1, underneath where it says print your name and sign your name, please do, it will say, please use proper significant figures for all calculated answers. If you don't, I take off a point. So please do. You've learned about it. We'll go over it today. And here, if degree C is 4 significant figures, 1.8 is exact number, 32 is exact number. If degree C is 4 significant figures, your answer should be 4 significant figures. If it's 2, your answer should be 2. Now, common mistake on the center middle formula is students, and do not do this, divide degrees F by 1.8, 32 by 1.8, and then do the subtraction. No, do degrees F minus 32, and then 1.8 divide by. Remember, 32 and 1.8 are exact numbers, and just like above here, if degrees F is, say, 5 significant figures, then your answer should be 5 significant figures. And finally, Kelvin is degrees C plus 273, and 273 is an exact number. Now, at this point, I do want to point out you should look before test number 1 in Blackboard lecture folder, and there's a file, both PDF and MS Word, important information, test number 1. This will be the last page of test number 1. In the past, I would have students memorize these formulas for temperature conversions. Now, I'm not testing your memory, but you do have to know how to use it, and there they are, and that will be on test number 1. Next, I talked about scientific notation. Scientific notation is a number, 1, never less than 1, never 10 and greater, between 1 and 9.9999 times 10 to the nth power. How to convert it? You move the decimal point to the right of the first integer, non-zero number. And if the number is greater than 10 and is positive, if the number is less than 1 and is negative. If the number is between, and notice I don't have it on here because I've never put it on a test, never will. If the number is between 1 and 10, n is 0. But anyways, let's do something I haven't done yet today. Why don't you write both of these in scientific notation? I've got to share some fun with you this morning. And I should do something that wasn't meant to be there, that little dot. It's 143,000. But this one, which I just did what I didn't want to, is meant to be there. Yeah, I think everybody's done, so I better get to work. How do you write A in scientific notation? Their word decimal point, it would be here, 1, 2, 3, 4, 5. Since there was no decimal point, I'm going to drop these zeros, 1.43, and I move that 1, 2, 3, 4, 5 times, so it's 10 to the 5th. This one, here's my decimal, there is one, but it's in the front. Move it 1, 2, 3. Lead zeros are always dropped, so that'd be 3.71 times 10. Notice I moved it 1, 2, 3. This number is less than 1, so this would be -3. And that's how you do it. If you're not sure, go back, and good way to study for test number 1 or any of my tests is do the practice problems. Ooh, time for a public service announcement from Dr. White. After test number 1, you'll understand why I call them practice problems. Hint, hint, wink, wink, say no more. That came from Monty Python and the Flying Circus, which is one of my all-time favorite TV programs. All right. Next, I taught you significant figures. And I'll never ask you what are the rules for significant figures, but you should know how to use them. All non-zero numbers are significant. Lead zeros are never significant. Confined zeros, those between non-zero numbers, are significant. And trailing zeros and no decimal point are never significant. Trailing zeros and a decimal point are significant. Again, all non-zero numbers are significant. Leading zeros are never significant. Confined zeros are significant. That means between two non-zero numbers. Trailing zeros, no decimal, are never significant, and trailing zeros and a decimal point are. So how many significant figures are in the following numbers? All right, there are a whole bunch of them for you to have fun with. Have fun, courtesy of Dr. White. Am I a nice guy or what? Uh-oh, it's being sarcastic.
Dr. White, can you move the screen up so we can see F, please?
Hold on. Is that better? Thank you, Sergio. And that's always a good request. I can't read that or move the screen. Aren't you glad Dr. White's a Zoom expert? I'm sure glad I developed this tablet. Actually, I heard about it from another faculty member at another school. He had just heard about it and we both bought it at the same time. And about a year and a half ago, a little longer, I started practicing my alphabet, my numbers, and now I'm pretty good at this. All right, let's get going. All right, A, all non-zero numbers are significant. Zeros at the end with no decimal. PT is point, no decimal point, are not. So this would be 3. Non-zero numbers are, oh, look, I have a decimal point. Zeros at the end with a decimal point are. So that's 1, 2, 3, 4, 5. Lead zeros with a decimal point are never significant. Non-zero numbers are, so that would be 2. Ooh, I've got a decimal point. Lead zeros are never significant. non-zero numbers are zeros after a decimal point are, so this would have 4. Now, tricky. Zeros, first of all, non-zero numbers are always significant, 3. Zeros confined are significant, 5. There's no decimal, so zeros at the end are not. So 1, 2, 3, 4, 5. This would be 5. And finally, F. Non-zero numbers are significant, 2 and 1. I've got a decimal point. Zeros at the end are always significant. So this one and this one are, that'd be 1, 2, 3, 4. And that's how you do significant figures. Next, I talked about rounding off. If you're doing something and you have something that's 7 significant figures, how do you round it off to 4 or 3 or 2? If the first digit to delete is 4 or less, drop it and everything that follows it, or replace it with zeros. Forget about that or. We really don't do that. In real life, you need to know that. For my class, I'll never have that on a test where you have to do that. If the first digit is delete is 5 or greater, drop it and all that follows. And let's see. All that follows, and the last retained digit is increased by 1. Let's do an example of each, or have you do one. If I were to do this on a test, I'd spell out significant figures. All right, why don't you try these 3, round them off to 3 significant figures. And can everybody see that on the screen? Thumbs up, people. Can you see it? Okay, thank you. And also, if I ever write anything too small for you to read, let me know. Or if my printing is illegible, you can always let me know by asking, what the heck is that? Be a little more polite, like, I can't read a word you're writing. Well, be a little more polite than that too. Again, round each of these off to 3 significant figures. All right, looks like just about everybody's done, so let's get to work. How do you round this off to three significant figures? Keep the 2, keep the 4, keep the 5. The number to round off is 6. That's 5 or greater. Drop those, increase this by 1, 2.46. Next one, keep the 3, keep the 1, keep the 1. Number to round off is 2. That's 4 or less. I'll drop that and everything afterward, and therefore this would be 3.11. 3.11 at no, I just put an extra 1 there. Let's look at C. Keep the 8, keep the 7, keep the 7. 8 is the round off. It's 5 or higher. I'm going to drop that, increase this by 1. So the answer would be 3.7. This is how I write my 7, 8. Now, D is a little tricky, but let's do it. Three significant figures. The same thing works if you're going to do 2, 5, whatever. But keep the 8, keep the 8, keep the 9. This is the number I use to round off, 7. It's 5 or greater. I'm going to drop that and any number after that and increase this by 1. Well, that becomes 0.1. So this would be, this increases by 1, which becomes a 0, which increases this by 1. So the answer would be 8.90. Now, we went through the operational rules for multiplication division. You get the same number of significant figures in your answer as the number you're multiplying or dividing that has the fewest significant figures. Again, for multiplication division, you get the same number of significant figures in your answer that the number you're multiplying or dividing that has the fewest significant figures. For addition, you get the same number of significant figures to the right of the decimal point that the number that has the fewest significant figures to the right of the decimal point. Everything to the left does not change. And we went through this in the problem set for Appendix A2, A4. Since I look at the clock, we're running on time. I'll ask you to A, look at the problem set, and B, look at the video. But one thing I should remind you right now, calculator for scientific notation, make sure it's set for scientific notation. Hit the second key and up here, mine it says SCIENG, which allows you to change between that. Next, to do scientific notation, to put it in, put the first number like 5.77, and then if it's 10 to the 5th, second key, double E. Most calculators have something like that, and then enter the number. And then times. Do not use this over here to enter scientific notation. Now, if your number is 10 to the minus whatever, enter the first number like 7.65, second key, double E, and then use the minus sign in the keyboard with the parentheses around it for a negative number 10 to the minus 10. Do not use the negative, the minus key over here. This is for subtraction. Use the negative key here in the keypad. And we went through that. You can go back and look at the video when I did that. That's the nice thing about having the video. By the way, luckily my office hours are before sundown. So if you have any questions or need any help, like with this, come to my office hour tonight on Zoom and whoa. Stay. But anyways, on Zoom from 5 to 6:15. All right. Remember, exact numbers are not considered when determining numbers of significant figure. I talked about the periodic table. You should know the first column is the alkali metals, second column is the alkaline earth metals, second to last column is the halogens, and the last column is the noble gases. Again, if I ask you, give an example of an alkali metal. Oh, hold on one sec. I didn't want to do that. Everybody see my periodic table and yours too on the screen? Thank you. If I ask you alkali metal, first column, but does not include hydrogen, and the ones I asked you to learn would be alkali metal, lithium, sodium, potassium. Alkaline earth metals, second column on the left, magnesium and calcium are examples. Halogens, second to last column on the right, fluorine, chlorine, bromine, iodine. And finally, the last column on the right, the noble gases, helium, neon, argon, krypton, and so on. You know, so on was an element, and you, oh, bad joke time, you can all boo. All right. And you should know what metals are elements are metals, such as silver, gold, copper, iron, are all examples of metals. All right, next, we finally start talking about some serious chemistry. And you should know the atom is the smallest particle of an element that has all the properties of that element. An atom is the smallest particle of an element that has all the properties of an element. Now, we talked about Dalton's atomic theory, and essentially that was elements are made up of atoms. There's a lot more to it, but I'm not going to ask you that. But you really should know the subatomic particles, electrons, protons, neutrons. You really should know. Electrons have a negative charge, protons have a positive charge, and neutrons have no charge. You should know that the nucleus is the center of the atom, and Rutherford's gold foil experiments helped clarify that, and that it was very dense. And you should know that the nucleus of an atom contains only protons and neutrons. The nucleus of an atom contains only protons and neutrons. And next thing you should know is the atomic number of an element equals the number of protons and the number of electrons. The atomic number of an element equals the number of protons and the number of electrons. And if we look at the periodic table, say for carbon C, the number in the upper right-hand corner, hopefully you know this is right, this is left, is 6, which tells me carbon has 6 electrons and 6 protons. If I look at gold, Au, the atomic number is 79. And that tells me gold, Au, chemical symbol, which you should know, has 79 protons, 79 electrons. And right next door, Hg, mercury, has 80, atomic number 80, 80 electrons, 80 protons. And next, where are the electrons? And the electron clouds around the nucleus. And there's shells and subshells. And for the electron shells, the shell names are 1, 2, 3, and 4. And the number of subshells, shell 1 has 1, 2 has 2, 3 has 3, 4 has 4. Now, if we go to important information, test number 1, you'll see I give that to you. What I don't show you is, and you should know, shell 1 is the lowest energy, shell 4 is the highest. And you always fill the lowest first before you go to the higher one. Now, you have the subshells and they're S, P, D, and F. And I will also, if you notice, in test number 1, important information, I give you that information. S has maximum number, 2 electrons, P, 6, D, 10, F, 14. Remember my secret gift to you, you only have to know how to do what's called electron configuration up to magnesium atomic number 12. That means you only have to know S and P. Remember, electron subshell is named by a number and a letter. Electron subshell is named by a number and a letter. And we went through examples how to do this in class. Go back and look at it, because you should know electron configuration, a statement of how many electrons an atom has in each of its subshells, and it's numbers and letters only, actually number, letter, and superscript number. Now, what I don't have here, and I should add to this, is I talked about valence electrons. So I'm going to do it the old-fashioned way. And you should know these are the outermost electrons of an atom. And how do you find that? It's the number on top the number on top of the periodic table. And if we go to the periodic table that you will use for test number 1 and 2, 3, and 4 in the final, you'll see in red, in case you don't know Roman numerals, column 1, hydrogen, lithium, sodium have 1 valence electron. The maximum you can have is 8. The noble gases, helium, neon, argon, and so on, have 8 valence electrons. And you should be able to, if I ask you how many valence electrons does, let's say calcium have? And you should know calcium, Ca, right over here, alkaline earth metals, second column, look on top, it has 2 valence electrons. And with that, that's the review. And I'll ask you, I won't, the question will say, are you done? But I'll ask you, answer yes. Did you like, was the review helpful? No, if it wasn't. This is secret, so I don't know who says what. Again, answer yes if you found the review useful. No, if it wasn't. All right, it looks like the yeses have won. Yay. Guess what? For test number 2, I'm going to do a review whether you like it or not. Well, you do like it, and it does help students. All right, any questions about test number 1 before I move on? I'm looking at the chat, nothing pops up. All right, we got a couple minutes and I'm not going to waste 3 minutes, so let's go back to chapter 5, part 1. This will be on test 2, not test 1. Remember, a mole is the counting unit of chemists, and 1 mole equals Avogadro's number of either atoms or molecules. And another way of putting that, you should know, one mole of an element equals 6.02 times 10 to the 23rd Avogadro's number of atoms of that element. And 1 mole of a compound equals Avogadro's number 6.02 times 10 to the 23rd molecules of that compound. Now, I just remember we got a minute left, so I've got time to make this important announcement. Listen carefully. On Friday, you'll be taking test number 1. I guarantee by Sunday, 1 p.m., probably earlier, but by Sunday, 1 p.m., I will have your scores in Blackboard. Once I post them in Blackboard, your test number 1 scores, I will send out, I'll post an announcement, which will also send out an email to you. I'm hoping sometime Saturday I'll get it done, but you never know, something might pop up. The other thing, by Sunday evening, I will have sent out individual emails to each of you showing you how many points you got for each answer you put down on test number 1. Also, on Monday in our lecture, I will go through all the answers for test number 1 so you can see what you got right and wrong. And I will also cut it out of the video because I don't want those answers floating around the internet for the rest of the time, which I do. If you can't make it Monday, feel free either to come after Tuesday lab and ask me to show any answers you want, or always feel free to come to my office hours. And with that, I'm done for today. For those of you who are celebrating Yom Kippur, I would say good Yontif, that's the proper greeting. And with that, I'll say Gang Gesund. Goodbye. Don't forget to wear your mask and get your vaccination if you haven't. Bye now.